Hi, I'm Steve Sobek. The purpose of this video is to show a sample tutoring session so that the viewers will get an idea of what it's like to have a tutoring session, a math tutoring session with me. Now, the topic of this particular lesson is solving exponential equations using logarithms. And my daughter Amy is out in California, and she's agreed to be our sample student today. Now, I'm assuming that Amy has already covered logarithms, and she's very familiar with the laws of logarithms, and that's the role that she's supposed to play. She's not the perfect person for that because she's been out of school for, what, 4 years, Amy?
Yeah.
She's been out of school for quite a while. It's been quite a long time since she's had logarithms, but she knows probably more than her mother does, and so she gets to be the guinea pig for this video today.
Yes.
Okay, so
It'll be very realistic in that way.
she'll
Gonna ask
be
lots of questions.
learning as if it was the first time. Okay, so now if you're not an Algebra 2 student, don't expect that you're going to understand everything that we do today, although you might learn something, but the purpose isn't to teach you how to solve exponential equations. It's for you to just see the different features that are available in a tutoring session, you know, that if you do tutoring with me. Okay, so let's get over to the first problem here. This is an exponential equation. We recognize it as such because the variable appears as an exponent. This happens to have meaning, this equation. If we were asked how long would it take a $2,000 lump sum investment to grow to $6,500 if we assume a 5% annual interest rate, then this is the equation that we would write to solve that. And so we're going to go through that with Amy here. And of all the laws of logarithms, there's one law that we are going to invoke in this problem that is very important that she understands. And so I'm going to take just a quick moment to review something she already knows, and that's this particular law. Okay, whenever you see a blue marker, that's Amy writing. Okay, so in a tutoring session, you know, both the teacher and the tutee, we both have pen tools, and we use different colors and distinguish between them. Okay, proceed.
Okay. So finding the log base 2 of 64.
Okay.
We're gonna do 2 times 2 is 4, 8, 16, 32, and 64. So 6 is the log base 2 of 64.
That's right. A logarithm is an exponent. She's trying to figure out, well, what exponent would you raise 2 to? 2 to what power works out to 64? And she found that 6 factors of 2 gives you 64. Consequently, that works out to a 6.
I feel so smart now.
All right, very good. All right, let's try the right side.
Okay.
Of logarithm. So anytime we have something that looks like the left side, we could take this exponent, n, and throw it down front as a coefficient, like we did here. We wrote it here and wrote it as n times the log base b of x. So it lets you take an exponent and bring it down as a coefficient. Very powerful, very applicable to solving exponential equations. All right, so that's a quick review of something that Amy already had, and she's got that, and we're ready to go back to that problem. And at some point in this problem, we're going to invoke that particular law of logarithms. All right, so we're trying to get this x by itself. And before we got into this chapter about logarithms, we had no way of isolating that x. You know, we had different properties of equality, the addition property of equality, subtraction. We could add the same thing to both sides, subtract the same thing from both sides, multiply both sides by the same thing, divide both sides by the same non-zero number, and we were always able to isolate the x through those four operations, and but that's inadequate for this problem. We need something new. We need logarithms. Now, initially we want to get this part right here by itself, 1.05 raised to the x power. So I want to get rid of this 2,000 over here, and so I'm going to divide both sides of this equation by 2,000. Okay, so that gives me, that'll cancel this 2,000 up here, and just leave me with 1.05 raised to the x power is equal to, now I could work this out, but put a decimal in here of some sort, but it's not necessary. Or I could
65 over 20.
Yeah, I could reduce it to 65 over 20. It reduces more than that, but there's no need to. We're going to be using a calculator to evaluate the logarithms, and so why introduce another chance of error? We'll just leave it like that. All right, now here's where we get something new. We want to be able to isolate this x, and adding and subtracting and multiplying and dividing both sides of the equation by the same thing doesn't cut it. Here's what does cut it. I am going to take the log of both sides. Since these two quantities are equal to each other, certainly if I take the log of the left side, it's going to be equal to the log of the right side, the log of all this stuff here. Okay? Equals the log of, I'll put this all in parentheses. All right. Now, you might be asking yourself, Amy, why did you use, there's no base specified for this logarithm, which means by default that is a base 10 log. You might be thinking, why use base 10 logs? Why not use base 7 logs or base 3 logs, Basically because your calculator will evaluate base 10 logs and base e logs, okay, natural logarithms. And so we could use either base 10 or base e, but not base 7. Our calculator doesn't do base 7 logs. And well, actually, it can. We have another property that can do that, and actually the newer calculators even may have that feature. But most standard scientific calculators do base 10 logs, and that's why we use base 10 logs.
Okay. I love calculators. Let's use the calculator.
We're not ready yet, okay? Until we get the x. When we get the x by itself, we'll evaluate what's on the other side.
Okay,
all right. So now
we have to find the log.
Well, we're not going to find a log of anything right now. We're going to evoke that property that lets me take this x and do what with that?
Put it in front of
Put it in front as a coefficient. That's right. So now it's going to be x, that exponent that was up here, okay, I'm going to draw an arrow here, is now, going to be moving down here. So now it's going to be x times the log of 1.05, which we could evaluate now or later. It doesn't matter. I prefer to wait till later. Okay, and we still got this over here on the other side. The log of 65/20ths. Which is, if you want to write 3.25, I mean, it's up to you. It doesn't matter. And to get this x by itself, just like, back when you were in 7th grade and you had a problem like x times 4 is equal to 20. What would you do to both sides to get rid of this 4?
Divide by 4.
You divide both sides by 4. We have x times this monster here equals something, and we're going to do the same thing. We're going to divide both sides by the log of 1.05.
Okay.
Yeah, same thing over here. Log, divide both sides by the same thing, the log of 1.05. All right. Now that will cancel this over here, leaving me with just
X.
x. Yeah, x times 1 over 1, which is just x. And now we're ready to pick up our calculator and evaluate this. Okay. Now I am going to show you my calculator. I have a TI-84 graphing calculator. So let me take a moment to bring that up on the screen. And I'll make that full screen for you guys. All right, can you see my calculator now, Amy?
Yes, I do.
All right. Now I'm going to type this in. The log, in parentheses, of 65 over 20. 65 divided by 20. Divided by the log of 1.05. And hit enter. And let's suppose we want this accurate to 2 decimal places. So 24.157 would run to 24.116. Okay, so I'm going to go back to the last screen. Help me remember that number, Aim. And let's go back to the problem. And let me write that in. That was
24.16.
24.16. That's right. If you wanted to check that answer, of course, a solution to an equation is a value for the variable that makes the original equation true. You would just plug this number back in here for x, since it's a rounded number, and evaluate this. You would just tick off 20 to 2,000 times 1.05 raised to the 24.16 power.
What? Wait, start over like 1 minute ago. Okay, wait, to check your answer, you plug it in by putting 24.16 in the place of x?
In the original problem, yeah, right up here. And you would just evaluate that on the calculator.
Okay.
And when you do, you would hope this all works out to a 6,500. Oh.
Yes.
It's a rounded number, so it's not going to equal that exactly, but it would be very close to that.
Okay.
So,
cool.
All right. So we're not going to take the time to check that right now, but if you were taking a test and you had time to check your answer, yeah, you would plug that back in and make sure that you would do that. All right. All right. Now, whenever we do tutoring sessions, like our many sessions we've had before, pretend, after I show you how to do a problem, I'll have you help me through a problem or 2 problems or 3. And then when I feel that you're strong enough, I'll have you do the problem and I'll help you as needed. Okay? But I do want to take a moment just because I want the viewers to see some of the capabilities that I have with the graphing calculator. To show an alternative method very quickly for solving this exponential equation. Remember that when we were solving linear equations and quadratic equations and cubic equations and quartic equations and all the other types of equations earlier in the textbook, that we were able to use graphing strategies to also solve those equations. And that same procedure applies here as well. And so if we go into y is equal to, and if those of you at home, if you wanted to take along with me and type in, the left side of the equation as y sub 1, 2000 times 1.05 raised to the x power.
And then for y.
No, you don't have a graphing calculator, so yeah, I guess you can't do that.
Right.
You didn't take your calculator to California. I can't believe you would leave something in Pittsburgh. Wow. Okay, y sub 2 is 6,500, the right side of the equation. And then we would select a suitable window. Okay, I chose x max to be 30. I'm figuring we're going to probably end up with that much money within 30 years. And my y max I set at 8,000. And we certainly have to go up at least to 6,500. And when we graph these, we get these two curves. Okay, this horizontal line is y is equal to 6,500. And this blue line is the graph of y is equal to 2,000 times 1.05 raised to the x power. And we're interested in when this blue line reaches the height of the red line. In other words, where do the lines intersect? And so we would hit second, calculate. Intersect is number 5. And it's blinking on the blue line right now, so we want to accept that as one of the curves. It's blinking on the red line, accept that as one of the curves. And then move to the right, and that's our best guess, and that's the third thing they want us to know. And once we do, it gives us the intersection point underneath the graph. You can see x is equal to 24.157, which we can round to 24.16. Amy, is that the same number that we got using logarithms to solve that problem?
It is.
Okay. All right. So, I rifled through this graphing strategy, assuming that you've used this for many other types of equations, and you were totally on top of that. That's why it seemed very, very rushed.
Yes, I was going to say, if I was actually trying to learn that, I would be asking so many questions in there.
Right.
But it turns out like logarithms are actually easier. It's easier to do the problem that way than probably learning how to do it on a graphics calculator. So.
Yeah. I mean, it would be faster just because we don't have to monkey around with establishing a suitable window for the graphs, But this doesn't take me very long, and people who, once you get comfortable with graphing strategies, this is pretty quick as well. But better than being quick, it's transferable to the equations that you'll encounter later in the book, as we get into some trigonometric equations and radical equations. It's the same graphing method. Graph the left side, graph the right side, see where they hit, and the x coordinate of the point of intersection is the solution to the equation. So sometimes there are multiple solutions, and so I wanted to just let you know that graphing method does work here. All right, but we want to get back to our main focus is solving exponential equations with logarithms, and so we are going to now move on to example 2, and this time I want you to help me through this problem. We want to find the value for x that would make this equation true. That means we're solving this exponential equation. All right, so, well, we're not going to even mention that word logarithm until this stuff is all by itself on one side of the equation. All right, so what do you suggest we do first, Amy?
We subtract 700. We subtract 40 from 7,000.
Right, we're going to subtract 40 from both sides. Subtract 40 from this side. And that leaves me with just 5 times 3 raised to the x power. And it doesn't matter whether this x is inside the parentheses or outside it. It's the same thing. Okay, and that will leave me with 6,960. Or you could just leave it 7,000 minus 40. You don't have to evaluate it since we're using a calculator ultimately. It doesn't matter. Proceed.
Okay. So now is now the time when I would take the x down?
No.
First, I would divide by 5.
Right, right. We want to get rid of this 5 here. So we're going to divide both sides by 5. And so that'll get rid of the 5 and leave me with just 3 raised to the x power is equal to, and I don't need to, yeah, I don't need to divide that. I'll just leave it like that.
Here, no, I'm using my calculator and cheating. It's 1,390.
All right, all right. Let me. For
the sake of the beauty of the equation.
All right. Let me get my marker back in action. All right. Read that to me.
1,390.
1,390.
Okay.
Right. All right. Good. All right. Do you remember what we should do next? Don't feel badly if you forget. I mean, this is just the first one that you're doing.
Okay. Would we find the log? Okay. Now, let's see. Now we can move the exponent in front of the log. So
that's right.
x
We'll
log,
take this exponent and drop it down here in front of the log. X log 3 is equal to log of 1,390. All right. You're doing great. But we're not there yet.
Okay.
Celebrate prematurely. We must refrain until we are finished. All right. What next?
Okay.
X is not by itself yet.
Right. So we need to divide by log 3.
That's right. We
on both sides.
Divide both sides by log of 3. Okay. Log of 3. And that'll cancel. These become 1s. So we end up with x times 1 over 1, which is x. And now we're ready to pick up our calculators and tick that off. All right. So you could do that on your calculator. Amy's using just an online calculator. No, she doesn't have a graphing calculator, but she could do that. And I am going to switch to my T84. And I might ask you, Amy, to, since I no longer see those numbers,
you know, I don't see those numbers either.
I think it was 1390, wasn't it?
It was log of 1390.
Okay.
Divided by log of something.
1390 divided by, and wasn't that the log of 3, wasn't it?
maybe.
Whoops.
We could say that. I don't remember. Okay.
Yeah,
That
I
would
think it
be
was log of 3.
3.46 rounded.
Now look at my screen.
Okay.
It doesn't say the same thing.
You're right. Log of 1,390 divided by log of 3. Let me try that again.
Yeah, try that again.
Log of
Make
1,000.
sure that you close your parentheses after you type in 1390. That would be a
I did
common
not
mistake.
do that. I did not do
Ah, okay. Viewers, beware. Common
that.
error that Amy fell prey to, for your benefit, of course. Just
I only did that for you. Of course, not.
for the team, okay. But
Okay,
with
I
the
got
parentheses.
6.59 rounded.
Okay, so 2 decimal places, that would be 6.59. Okay, so I'm going to go back to our whiteboard. And let's type in the answer here. Okay. 6.59. That's the solution to the equation, which means that's the value that makes the original equation true. And if you were taking a major test and you had time to check your answer, you would plug that value of x back into here and take 5 times 3 raised to the 6.59 power plus 40 and hope that it worked out to something pretty doggone close to 7,000, affirming the correctness of your solution. Hey, you did pretty good, Aim.
Thanks. That was kind of fun.
All right. And I could read your mind. I know just what you're thinking. Dad, let me try one on my own. Hey, I got one
Yes.
just for you. All right. How about you take your pen tool, and Amy's going to be writing in blue, and she is going to attack this problem, and I'll help her out if she needs to.
Now, here comes the log part. So now I need to add log base 10 to both sides. I mean, multiply.
Well,
Log.
you're not adding or multiplying. You're taking the log of
Am I
both
doing
sides.
anything? Okay.
Okay. Yeah.
Okay.
Yeah. I usually leave a bigger gap between the equal sign and the 2,325. But you could probably squeeze it in.
Okay. Whoa. Oops. Okay. Uh, here we go.
Look at that. Look at that. She did it. All right.
All right.
Excellent.
Now,
Now, why did you log both sides? What good is that? It looks more complicated.
because once you log both sides, you can take the x and put it in front of the log.
We could use the law of logarithms to take that exponent x and bring it down as a coefficient.
Log 2325.
2325 in parentheses, don't forget that. I'm going to go to my calculator just to make sure that I get the same answer that you get.
The
Not
numbers
the
were there. What was it divided by?
log of 5.
Oh, yeah.
Log of
Okay.
2325
I got 4.82.
divided
See if
by
I
the
did it right.
log of 5.
Yes.
4.8, I guess if you round to 2 decimal places, 4.82. That's what you said, right?
Yep.
Good call. By Jove, I think you've got it.
I think I've got it.
And let me go back to here and let you write your answer in then.
Okay. Get my marker out. Whoa, whoops, that didn't work. Okay. 4.82. Yay!
Okay, it looks like a negative sign in front of it. Oh, okay, you're just accentuating the answer.
Now I am. Yeah.
All right, you did a great job,
Yay.
Amy. And I think if viewers out there should give her a round of applause for taking on this endeavor, knowing that it's been many years since she's had exponents and
You make me
logarithms
sound old. It's been 4 years.
since she graduated. Yeah, but
Yeah.
she's did a great job, and she can solve exponential equations. And any of you listeners out there are interested in doing some tutoring with me, I'll be glad to help you with that. And if you go to my website, Amy, what's our web address?
amysflashcards.com.
Yeah, that's right. If you go to amysflashcards.com, you'll see a hyperlink that would take you to the one-on-one tutoring page. And then upon doing so, you'll see all the details. And at the very bottom of that page, there's a tutoring request form where you would just, type in your name and what would you like help with, and what would be the email address, and I will evaluate that. And if I can help you, I'll send you a hyperlink you just have to click the hyperlink to get into my tutoring room, and then I can help you. So I hope that some of you are able to take advantage of that, and thanks, Amy, for your help. And I think we could end the video. How's that sound?
Sounds great. Think we're good.
All right. Thank you again.